Hello everyone, welcome to the NN Classroom. Today I'd like to share with you multiple choice question number 3 about mole concept extracted from 2017 time zone 0 in November. Let's see, what is the pressure in Pascal? So my answer is going to be expressed in Pascal. Inside a 1 meter cube of cylinder containing 10 kilograms of hydrogen gas at 25 degrees Celsius, and given the universal gas constant is going to be 8.31, and then also the equation, which is really classic, the ideal gas equation, PV equals nRT. So you may see this is not a difficult one, but simply asking for substitution of the numbers, right? But still, some students are having difficulties in terms of substituting the right unit of the numbers into the ideal gas equation, which is really important, right? So now I will tell you, across this equation, PV equals nRT, right? Normally, there are two ways for us to plug in the numbers, or we can say two sets of conditions that we can plug in. Usually, the first set is that if you are going to be all SI unit, the standard international unit, then the pressure will be going to be Pascal, and the volume will be in meter cube, and the moles, which is going to be mole, basically you can say no unit, and the R is going to be 8.31 in the IB syllabus, and finally temperature in Kelvin. So this is the first way to plug in all the numbers to prevent getting wrong answers, right? So if it's Pascal, then all SI unit will be meter cube, moles 8.31, and temperature must be in Kelvin. Or another way to do the substitution is also pretty classic in chemistry, is that if the pressure you put is in kilopascal, then the volume can be changed to decimeter cube, so dm cube. But the rest of the units is going to be the same, moles in a mole, and then R 8.31, and finally temperature in Kelvin. So do remind you that whenever what unit they were plugging in, temperature is always going to be absolute temperature, Kelvin, but not in any degree Celsius or Fahrenheit, right? Makes sense? So for this case, obviously, we are going to use plan number 1, right? Why? Because what we are finding is also in Pascal, right? And what we are given is also in meter cubes. So that's why you can see this time the question is not so tricky, pretty direct, as the unit is already coherent, right? Otherwise, if they give me the dm cube, better to switch back to m cube before plugging into this equation. Otherwise, your answers may get several thousand times wrong from the original, right? So far so good, right? So for this case, I will be using this equation, and my subject is going to be the pressure, right? So make sure you put the pressure as the subject. So that's why nRT over the volume, V, will be my expression, right? So continuously I plug in the numbers, right? First, which is the N. N stands for the number of moles, right? Obviously, for this case, the moles is not directly given, but we can work it out because given the mass of the subject, hydrogen gas, right? And always we know the moles can be worked out by mass over molar mass, right? And so still times the R times the T over the V, right? So continue. So the mass, remember when you work out the moles, the mass is going to be grams, right? Yeah, so that's why for this case, the mass is going to be 10 times 1,000, switch it back to grams, and then divided by the molar mass, right? Obviously, you should notice the molar mass is going to be around 2, because hydrogen with the relative atomic mass of 1, so H2 will be 2, times the R, which is the universal gas constant as given 8.31 here, and times the temperature, remember in Kelvin, right? So 25 degrees Celsius plus 273, we will get 298. And finally, divided by the volume, and the volume is going to be, in this case, 1, right? Yeah, so let's simplify a little bit of it, then you will get 10 over 2 first, that will be 5. And 5 times 1,000 in our given expression, this is going to be 10 to the power cube, and then times 8.31 times 298, finally divided by 1, don't miss it, or 1.0. So obviously our answer that matching will be D.